Okay, hey everybody, this is Lisa Verzella, and I'm going to walk you through XCSkies. But first, I want to mention real quick XCSkies is actually the sixth step in the process that I have of analyzing weather and where the best and safest and most fun places are to fly each time I want to go out. So I can just walk you through a couple real quick of the previous five. I've got a couple of things to show you, and then whatever I haven't shown you will be available in the show note links. So, first thing, I definitely like to look at the big picture. So, a lot of stuff is available on the National Weather Service page. Yes, I'm a little biased because I work for the National Weather Service, but I also know where a lot of those products are, and they've been really helpful for me. So, to find your local National Weather Service, you can bring up weather.gov, super simple link. And then if you can see my cursor here, just go to the state that you're in. And most states have multiple offices. So just kind of zoom in or just put your mouse over the area of the state that you're in. For instance, like Colorado has 3. So if I put my mouse up here in the corner and then I click, it'll show you the area of that weather service. Actually has a little bit of Utah. So since I'm most familiar with it, and of course, whatever you click will show up. So that's the Grand Junction office. I'm going to go back and I'm going to go to the Salt Lake office. So I'll click here. And so most of the pages are set up in a similar manner. So you can find a lot of what I'm discussing on here. And again, I'll put more direct links in the show notes. But first thing I start off is like I said, the big picture. I know a lot of pilots like to look at the surface winds, but that's definitely, I like to do the top down. That's been really successful for me. So I'll look at the upper air analyses. I'll start out with the stuff that's up at 18,000 feet. That's the 500 millibar chart. And that will give me the big picture. Where are the ridges, the nicer, calmer weather? Where are the troughs, the features that indicate that weather's coming, and where the interfaces of the lift and the instability might be. So it just kind of gives me a general snapshot. And then I'll move down to the 700 millibar layer. That's about 10,000 feet. For us in Salt Lake, that's the top of the Wasatch. So that's a really important layer because it will tell me winds and all of the parameters that are happening right about ridgetop. So you still got terrain to deal with there. And then I'll take it down to the surface. So that's generally the first thing I'll do is the big picture outlook. And I'll look at winds, I'll look at relative humidity, I'll look at a lot of the different parameters that are available on those charts. Again, I'll put a link up for that. The second thing I look at is surface charts. So again, now I'm looking at the surface, kind of get an idea of what those winds might be. The third thing I'll look at is satellite. The visible imagery will show you the clouds, and when you loop it, you see the actual motion of the clouds. So a lot of times that's up super high, but you get a general picture of the big view. And then I'll look at radar just in case I'm on the edge of something and there is precipitation in the area. It's always nice to see. Sometimes we'll have a big day planned out and I'll forget to look out the window and we'll get halfway out to the site and we'll see that it's like raining over the site. So radar is definitely a good thing to look at. So that's the third thing is the satellite and radar. And then I'll get into the forecast discussion. And that's usually very visible on your page. So on our page, you scroll down and you have a lot of icons here. So I just pick the one that says forecast discussion. And don't be put off. Sometimes there are technical terms. Most of the terms have a link to them, like cold front, and they'll discuss it, and trough, and circulation, where actually it shows you right here. That gives you a little description of what it is. So these are super helpful. It just gives you kind of an overall synopsis, an overall look at what's happening, big picture. And then it gives the short term. And then you can move into the long term, which is usually 3 or more days out in case you want to start planning. So again, really helpful stuff. So that is my fourth step. And then I'll go back to the main page. And there are at least half a dozen offices in the country, if not more, that have soaring forecasts. And we've worked really hard in the Salt Lake office to develop a real good and thorough soaring forecast to emulate Boulder, Colorado's soaring forecast. They're the kings and queens of the soaring forecast because they have a big soaring glider sailplane community. So they also, I think they're the only ones maybe in the country that offer the wave indexes as well. I could be wrong. There could be some in Albuquerque. But again, for us, it's under aviation tab, and I think these other states it'll be as well, and forecast charts. And here's kind of a one-stop shop for the ones that we know about. As far as soaring forecast, you've got Nevada, Sierras, Flagstaff, Albuquerque. There's one in Grand Junction I know about, and somebody called me a few months ago and wanted me to bug I think it was Riverton, somewhere up in Wyoming office. So we sent some pleas up there to get one going. I don't know if they have yet, but you can always call your local office and beg them for a soaring forecast product. So ours is updated every morning. So how the soaring forecast works is weather balloons are sent up from not every weather service office, but a lot of them, over 24 in the country. Every morning in the summer, they're sent up at 5 a.m. and they usually finish readings by 7 a.m. And the direct observations are translated down through a little radar. So we have direct observational winds. Let's see, this one is cut off for some reason. So I'm going to go to an older one and see. All right, there it is. There's the full product. So you'll look at your date, make sure it's the current date, and basically you'll have the observed winds that morning. You'll have all of the observed information, and then this is plotted on the SKU-TU, which I'm sure a lot of you have heard about. It's kind of this theoretical chart where you can plot your numbers, and it creates an idealized atmosphere based on those numbers that will give you forecasts for a lot of upper air parameters. And it mentions, it just goes through a few here. Maximum temperature, the time of trigger temperature. I won't go through a lot of this stuff, but basically it takes the current observations and it makes an algorithm and comes up with a lot of the soaring parameters that we look for. And again, like any forecast is only as good as its starting parameters. So you want to look at these, you know that they're actual observations, but further down we get into the models. And we want to check, okay, our models, are they similar to the observations? And that's what a lot of people forget, especially the day of. Whatever model you're looking at, you want to make sure what you're starting with is kind of close to your observations, or else your model doesn't have a lot of weight. So anyway, this product is definitely something that I hone in on, and a lot of our cross-country pilots, I think, in the area do. And you can interpolate it. It's Salt Lake. It's for kind of northern Utah, but you can interpolate as you get further south and deeper into the mountains. So that is that product. And that was that was the fifth. And so after that, then I go into kind of the answers. And that's the XCSkies. So we're going to go to this tab here. So for those of you not familiar with it, you can get on XCSkies.com. There is a subscription fee. I think it's $4.95 a month, or you get a discount if you sign up for 6 months or a year. Very worth every penny. And one of the main creators, Chris Galli, I wish he were on the show here too, but I'm trying to convey as much as I can of his product and maintain the integrity. But he is definitely worth much more than that. So you can go month to month for it too, and just give it a try. But this is what you'll see when you go to the home page. You can create an account and get in. And it looks like we have tutorials up. This might be, this is as of today. has been added back in. So this is a fantastic place to start. This is basically everything I'm going to talk about. So this documentation and tutorials page, it tells you how to sign in, set up your parameters, where you want to fly, what models you want to use. You can name your sites, your profile. If you're, 3 hours away from Greenwich Mean Time, or 6 hours, like here in Salt Lake, we're in the summertime, we're 6 hours off of Greenwich Mean Time. So you can set up all these things, and this tutorial walks you through that, understanding the basics, and then the map parameters, which I will delve into more on the understanding the wind barbs, and then all the forecast tools that you can use. So I'm going to be going through a lot of these, maybe skimming some, but again, if you have any questions, I'll have my email in the show notes and you can contact me. So I'm going to start with the map parameter, but I'm going to do it through the page itself. I'm going to go to my page. Let's see if I can get out of home. Since I already signed up, I'm going to go into my forecasts. So I have it honed in on the Utah area. And we're going to just start from the parameters here on the side. So this is what I have set up. I'm 6 hours behind Zulu time, Greenwich Mean Time, whatever you want to call that line, the international date line. And this is a little clock icon over here. So I'm going to get rid of that. And here is the area that I fly in. I'll expand that a little so we can get our bearings here for all the folks that aren't from Utah. You can do this with the mouse on your computer as well. Just expand the screen. All right, so we've got the United States of America. And so the entire state of Utah is right in here. And so it's great to get kind of a big picture view. And there's a lot of information in this. So let me hone in just a little closer so it's not too overwhelming. Here's the Salt Lake area. And I'm just going to go through the parameters. As you can see, when you scroll down, it gives you a little box that explains it. And this is kind of a summation of the actual tutorial explanation. So if this doesn't explain it fully to you, go back, and you'll be going back and forth to that tutorial until you really get a handle on it. I have to look at the tutorial every once in a while when I'm dealing with thermal indexes and maybe things I don't look at very frequently. So it starts, I'm going to go through top to bottom, but you don't necessarily have to use that. And as you hone your XCSkies skills and what you're using it for, I basically have like my top 5 out of all of these. So I'll briefly go through all of them. I'll talk about my top 5, and then I'll talk about some of the tools you can use to look at like your whole flight area. And I hope this is not too much for folks, but we'll see. We'll give it a try. All right, so top of usable lift is like it sounds, and it's in mean sea level. So a lot of the default settings are going to be mean sea level, so it relates to everybody. So 18,000 feet is X number of feet above wherever the surface of your area is. So, and we are capped by 18,000 feet as far as a class. I believe it's Class E airspace. So that's a pretty pivotal number for us. But top of usable lift, for each of these parameters, it shows you a scale over here. So, I know these colors in my sleep, but get familiar with them and you'll realize that, okay, usually out in the valleys, we're going to have a pretty low top, and that's 7,000 or 8,000, which I know is about $4,000 above the valley floor, which, you can work with to some degree. As you get into the mountains, you'll see that it goes into the reds up here. And then as you get to like some of the higher peaks of the Uintas, you're up to 15, 16K. So that shows you about top of usable lift. For that particular model for that particular day at that particular hour. So that will come in a second. Next one, lift above the ground. So now we're talking about AGL, above ground level. So it's a kind of conversion of usable lift. Use whatever one you're comfortable with. Thermal tops. Okay, so we'll go to lift above the ground, and that's going to look a little lower because again, you're taking out the surface elevation. Thermal tops. How tall are those? How tall is the lift column going to be? Basically, just according to that SKU-T, according to the numbers. Doesn't have to do with your sink rate, and there's a lot of other parameters that might interfere with it. So it's just kind of a basic look, and it looks pretty similar to top of usable lift. Sometimes thermal tops can be a little higher, but see, it's pretty similar. So thermal top uncertainty, a little advanced. This is basically tells you if an area is a little more susceptible if there's more heat applied to it, and it may be an indication of some overdevelopment. So it's the height difference of the thermal tops. If the surface were heated an additional single degree, indicates air mass sensitivity to additional heat. So let's look at these places now. We know that the Uintas are going big. We know this area south of Richfield is pretty high. Let's see what the difference is. Let's see. That color is just about 1,000 K. Let's see. This is the lake, so you can ignore that. Probably another little lake. So basically, you don't have much difference. You have 0 to 2,000 K. So it's not a variable that I deal with, so I don't really worry about it, but that's just an explanation of it. Updraft velocity, that's some interesting stuff. Again, you're going to subtract probably about 300 feet per minute, hang gliders and paragliders. Sailplanes would probably subtract 100 to 150 feet per minute, but this is basically what the models say you're going to get. Again, this model at this day, at this time, shows that over the mountains back here, you're going to have, okay, let's say 900 minus 3, you're going to have 600 foot per minute average thermals. That's a pretty rocking day. So we know we've got a good amount of instability there. Okay, so that's updraft. And then buoyancy to shear. So that there's a little bug in this model. In this version, I guess it is, of XCSkies. Basically, let's look at it as the buoyancy is, how buoyant the air is, how lifty is your air. And the shear is how much does the wind and the other factors want to pull it apart. So you want good buoyancy. You don't want those thermals ripped apart. So obviously, if it's a ratio, you want your buoyancy to be a higher number, and you want the overall number to be higher. So we are looking at, this one is not the one with the bug, sorry. This is, it's a good thing to glance at, but it's not super accurate in the mountains because there's just too much variation in topography. So I don't use it as one of my top 5, but it's interesting to look at, fly, and see how it compared. That's a real good way to get familiar with XCSkies, to do post-analysis. Anywho, this is your buoyancy. So it looks, and basically anything above 5, I think it mentions it here, values of 5 and above typically indicate thermals will not be broken by wind shear turbulence. So higher number, the better. XC potential is a little, as it says, experimental. Since the buoyancy shear ratio is not super accurate in the mountains because it's extremely variable, buoyancy shear is one of 4 variables in the XC potential. So it's described in the tutorial as, it says here, target audience is an intermediate paraglider pilot, which is not that much different than hang gliders, I would say. But that being said, it mentioned something in the tutorial about safety. And if we're looking at the big picture of it, you definitely want more parameters than just an overall look. So take this with a grain of salt. You can look at it. It's not one of my big five, but weight it accordingly. All right, CAPE is a biggie. CAPE is, as it says, convective available potential energy, and you hear this term a lot in your cross-country days. So it's the amount of buoyant energy to accelerate that particle. So basically, it's the amount of juice that can result in overdevelopment. The value says values above 1,000, but in the Intermountain West, I've seen it blow up with a forecast of 350. So if I see this color, let's move it. It gets a little more exciting on Sunday. So I'm going to move this to Sunday so we can see. Okay, so now we've got some action going on. I knew we have a little system coming. So we've got all this area at 1 o'clock in the afternoon of 0 to 300. I'm not going to be too concerned about that. When it gets to 300 to 600, I know to look out. There's probably going to be some isolated development in here. Again, this is not the only variable, but it's a pretty significant one that plays a role in the possibility of overdevelopment. And then the Richfield area is going to be like target. That's probably going to be developed there according to CAPE. So that's just something I put aside. Okay, I really need to look at those areas. Then I go to the lifted index, which is another indicator of instability. And it's very correlating with the CAPE. So on a quick technical sentence for lifted index, let me quickly talk about the overall thermal index here. And this is where we have a little bug, but I'm going to explain the concept of thermal index real quick. So we have our observations in the morning from a balloon. The balloon goes up and it captures the actual air temperature, all the parameters, the humidity, the pressure, the winds. So that is your called environmental parcel. It's the real one. So we take that and we plot it, throw it onto here we go, the SKU-T again. We plot it onto a model. Basically, it's not really, I wouldn't call it a model. I'd call it like a tool to analyze our data. So we throw the environmental air onto the tool and we create an idealized parcel out of that's created from the tool. So what we're doing is we're bringing these two parcels, we're lifting these two parcels, the real one and the ideal one. We're lifting them up and we're comparing the temperatures at different altitudes. So the thermal index is the different altitudes. Let's see. The way that it's arranged here, it looks like we did go next. Okay, I think we got the bug worked out. This is excellent. Well, we don't have a lot of numbers to deal with here. So basically, just remember that the thermal index is the difference between the environmental parcel and the ideal parcel. If you raise this ideal parcel and it's warmer than your real air, it's going to keep rising. That's an unstable parcel. So your numbers, as long as that ideal parcel is warmer, your numbers are going to be negative. So negative index is an unstable, is instability. And you can see that since it's been adjusted over here. So the more unstable the parcel is, the more negative a parcel is, the more unstable it is. So, which is not necessarily a good or bad thing at the moment. It's just something to be aware of. That means a negative number means your parcel is still going to rise, still needs to cool off. Okay, so that's enough of the science. And so what I like to look at the most is the lifted index. And that has developed a lot over the years to where we can get pretty low or pretty high resolution models that show not the GFS like 24 kilometer model, but we can get it down to like a 3 kilometer parcel that you're looking at. So you can really capture the kind of the nooks and crannies of some of these mountain areas. So you're taking the lifted index is that thermal index, but you're looking at those two parcels, the real and the ideal, at 18,000 feet. So if your ideal parcel is still warmer than your real one at 18,000 feet, it's still going up. And we would all love to have rising air going all the way from the surface to 18,000 feet, because that's our goal. So it's the -1, which is this little color right here, the yellow. And Chris and the inventors of XCSkies may disagree with me, but I always find the -1 is the sweet spot here. Any more than that might be a little stable. We've had good results around the Wasatch in the mountains with this light green here, the 0 to 1. But this is definitely your sweet spot. If it becomes more negative to -2, -3, -3 is generally going to blow up. That's going to be an overdevelopment situation. So judging from the CAPE and the lifted index, in Richfield, we have close to a -3. So that's the area to avoid that's early. That's at noon. We can jump ahead real quick and see, okay, what's it going to do at 3 o'clock? It's my clock again. And it's extended itself. So the lifted index has become more negative in more places. So it kind of gives you an idea of that instability. Again, sweet spot. I love that yellow. Okay, so that's just a quick look at the lifted index. We talked about the thermal index. Now, those
Lisa,
are all...
can I jump in on the thermal index there? That I'd lost you a bit just because of if you click back on that,
Okay.
the colors, wouldn't we see a similar color arrangement to lifted index?
No, sorry. This is the average of the whole boundary layer from the
Oh,
surface all the way up. Yeah, that's an excellent point. So we are not seeing that variation.
okay. Gotcha.
So, but we do want, it's kind of a big picture. We want to glance at where are those negative areas, but there's not really any change here. So for me, I don't use the thermal index as a part of my big five.
Okay.
But there may be situations where it shows you some information.
Gotcha.
Does that help?
Yep. Thank you.
Okay, cool. So that wraps up the biggest third chunk of the parameters, the thermal parameters. And the next ones down here are weather. I'm going to take a quick second to hop over here and show you that all of these parameters can be examined. Usually it's just the winds that change at all of these. These are different levels, and these are mean sea level again. So for Salt Lake, it does have a surface wind. A lot of my sites are between 6 and 10. So you can click on the different elevations. Let's get off this page so we see something other than blue. How about lifted index? So you can see how the wind barbs will change. And I'll talk about wind barbs when we get down to wind surface at the end here. Anyway, that's just briefly, you can change the elevations over here. You can change the model here, and it goes from the biggest spatial resolution of 24 kilometers and the most number of days out ahead down to 3 kilometers. Sorry, the NAM, I guess. The NAM is 12 kilometers. And then the NAM 3 is 3 kilometers, and the HER is 3 kilometers. So it basically goes in the biggest to the smallest resolution. These models at the left end don't update super often. These models down here update a little more, with the HER updating in real time every hour. I'm not sure how often XCSkies updates it, but this takes hourly observations. So, okay, so I'm going to jump back in to the weather parameters, and cloud-based is definitely one of the big five. And it's definitely gotten more accurate over the years, especially with the higher resolution down to the 3 kilometer. Again, get familiar with your site and how these models relate to your site, so you can weight this parameter accordingly. But it's been pretty good for us this spring. We like the day of, we like to use, like the NAM 3 kilometer. But in general, I don't want to get ahead of myself here. So this shows the height again in mean sea level, and it's the convective cloud level. I'd say it relates for us more to cloud base. So a real-time cloud base. This has been pretty darn accurate for us. The altitude where the dew point is reached by a parcel of air. So it's where all of the potential water vapor condenses and basically is cloud base. Cloud depth is a good one because it tells you, how deep are those clouds going to get? And that gives you an indication of whether something's going to overdevelop. So look again, here we go. Here's the yellows, and that equates to 18,000 feet of depth. So that's so far our third parameter indicator that we might have some overdevelopment there. So just things to keep in mind. Cloud cover. This may seem intimidating at first, like, oh my gosh, there's, 90 to 100% of cloud cover. But as you'll see, not all of these parameters are available in all of these models. But in the GFS, you can take out the high clouds right here. Look how much less cloud cover that is. High clouds, they may impact flying a little bit depending on how thick they are, but definitely not something to say, oh, it's going to shut us down or it's going to get super scary in this entire lower half of the screen. That looks that. But if you take out those high clouds, which may be thin, then it's a little spottier. It's a little more sparse. You can work with that a little more. And again, this is at 3 o'clock in the afternoon. What might that look like at noon? Not very much at noon. So you might equate that with an earlier day. Okay, precipitation is another kind of answer or result of all these other variables. GFS will show you big splotches because it's 24 kilometer. Let's get an idea from, let's say, the NAM 12. It doesn't go out that far, of course. And we'll talk about that as well. So let's say should go out to Friday. Friday is just showing a little splotch up here. So you can find out approximately where they'll be. Let's think about that Richfield place that we were looking at on Sunday, I think it was. I'll have to go back to the GFS. And, there it is at noon. Okay. I wonder what it's like at 3. There it is. And it's more extended along the mountain range. So indicator number 4 that we may have some overdevelopment there. Get rid of my clock. Precipitable water column. So this is the total amount of water vapor that's in the air. It's how much water, like if you took a towel and you wrung it out, how much rain would it produce? So our numbers over here for these green colors are like 4 millimeters up to 9 millimeters. An inch is 25, and that's when you're starting to get concerned. Although we have, look, again, in Richfield, we're getting close to an inch. We're up here in this zone. And I find that really above a half an inch, if you have all the other parameters, you'll start wringing that towel out and you'll probably get some form of water, even if it's spotty. So that is the precipitable water. Relative humidity. So this is the average all the way from the surface to the thermal top. So it's I don't use this very much because it's just a pretty big average. But if you do have a high RH, which is these colors up here, that can be another indicator of potential overdevelopment. We have some darker colors here, and we have some over the Uintas. So yet another parameter indicating something's going on. Okay, so wind. So you've been looking at these little black things the whole time, and most of you are familiar with them, but for those that are not or don't see them that often, these are wind barbs, and there's a kind of a longer one and a shorter one. The short ones are 5 knots, I believe. Let's see if this program tells us. Let's go to, it'll tell you in the tutorial, I'm sure. But let's see, it doesn't tell us here. I'm going to call them, there they are, miles per hour. Just always look at your legend. So we got miles per hour. So we got the little barb of 5, the big one of 10. So that's 15. These are 20s. Out here in the West Desert, we've got 30s, 25s, and 30s. So, and they're color coded as well. So you've got that in the legend to help you out. So this parameter is wind speed at the top of usable lift. So if your day is pretty high, you are going to be above the terrain, but it's still going to influence you. And when you're flying in the mountains, winds above, for me, winds above 15 are no bueno. A lot of folks deal with 20 or 25 mile an hour winds if you're higher up. That's definitely not my style. But this gives you an indication. I'd say if you don't know your style, ease into it and don't put yourself in a position of more than 10 in the mountains. But so this will kind of help you see where those areas are. It's not blowing 30 everywhere. And, you know, obviously your top of this contours the top of the lift. So your top of the lift is going to be not as high here as it is here. So it kind of follows. It's not a particular layer of 10,000 feet or 12,000 feet. It's wherever you might be if you're at the top of the thermal. So definitely something to consider. Okay, surface temperature, just fun to see where it's going to be warm and not. This will give you an idea of the freezing level. Last week, we had a freezing level at, I think it was 16,000 feet. It was so nice. Yesterday's freezing level was 10,500, and it was so cold. And so it's nice to see, look into the future and see how it's going to warm up. So I'll just give you a quick overview of that so you can see the fields. So we've got yellows here, which is about 75. And that's tomorrow. We have a little cold front going through here. Let's see, on Thursday, a little more expanding of the yellow. I'm sorry. There we go. Into Friday, more expanding of the yellow. And by the time we get to Saturday, we've got some 85s down here in the south, more 75s up north. By Sunday, we definitely have more areas of 85. So we're definitely in a warming trend. You already would have known that by looking at the big picture, and this will correlate with your freezing level as well. So you know you might be comfortable on Sunday if it weren't blowing 30.
Lisa, show me again, how are you finding the temperature at base in a scenario like that? So these are the surface temps.
Right. There's actually another product to look at temperature at base. So this is just the surface temperature. Mm-hmm. So this product won't give you base, but if you see the trend that I just pointed out, where I knew there was, kind of a cool front Thursday, and you can tell that the warmer air is moving up and expanding in the state. So that's going to move through the boundary layer, and your freezing level is going to get higher and higher. So this just gives you an overall view of that. And I think when we get into obviously your soaring forecast will give you the freezing level that morning. And they've been pretty accurate. I was freezing my butt off yesterday. Meantime, there's another pilot that I was flying with who went to 17.7, I think, maybe higher. I don't know how he did it, but he was able to hang in there. So surface heat flux, I don't look at this number often, but it involves, so it acts as a trigger mechanism to release thermals. And the higher, let's see, get down on my screen here. Sorry. Higher fluxes will give you stronger thermals. I don't use this one very often. Let me zoom back in here. Apologies. But I know that it incorporates sky cloud cover, soil moisture that's in some of the models, and solar radiation. So if you want to use that, that's something you can learn about. It's also better explained in the tutorial. And then mean sea level pressure is interesting. This is kind of equates all of the areas, kind of takes out the elevation. So it shows you in the bigger picture when we zoom out kind of where the high pressure is. So the darker numbers are closer to like 1,020 millibars. Excuse me. If you take standard atmospheric pressure, it's I believe 1,000 or 1,010. I forget millibars. So that's like, just say 1,000 is kind of your neutral point. If you're above that, you're in kind of a higher pressure regime. If you're below that, you're in the 900s. In the blues over here, you're in a low pressure regime. So let's get back to today. All right, so mean sea level pressure shows kind of equalizes all of the elevations and altitudes out. So we're all kind of starting from the same level. And at sea level, about 1,000 millibars is, let's say that's the 0 point. And above 1,000 is high pressure. You see some that's actually in the 1,020s here on the map. And things below 1,000 is generally a lower pressure regime. So if we look at tomorrow, we know we have a front coming through. So post-frontal, we've definitely got higher pressure here, getting up pretty high in the north, whereas that system that just passed through, here's the low pressure. So here's that system. And again, this is kind of big picture. I've got it on 12,000 foot winds right now because that's kind of, for us in the Wasatch, that's pretty much the layer right above the peak. So it's kind of a critical decision layer for us. I could just as easily have it on top of lift. But sometimes that's a little misleading because you might see a light top of lift and assume that everything below it is as light or lighter, which is not the case. So you can toggle back and forth to figure out what works best for you. So we take that pressure map and we go, into Friday, see a little bit lighter, and Saturday even lighter. And then by Sunday, we've got this low pressure regime coming in. So another big picture look. So that's it for the parameters. Now we're going to look over here at what I've been kind of clicking on. Talk a little bit about the wind barbs. I think I started talking and then I got distracted. So we've got our wind speeds. We're looking at 10, we're looking at 20. And remember that it shows you as if you're shooting an arrow. So this indicates the direction the wind is coming from. So the wind in this instance is moving from the southwest to the northeast. And here you've got a little wind barb that's actually moving kind of from the west to the east, a little bit northwest to southeast. So it's just like shooting an arrow where the fluffy stuff is at the back. And this is the direction it's heading. And to remind folks, the name of the wind is always the direction it's coming from. So this is a southwest wind. Here you've got this one area where it's a northwest wind. So that's just super brief reminder on barbs. This is an interesting feature. I didn't even know it existed, but you can do a barbs image, which makes it, for those of us that have hard time seeing the page, it makes it bigger. It also tends to add, it sometimes adds a barb or subtracts a barb because these little numbers here are the, let's see, I believe they're the miles per hour. So you might see something that was 11 is now 13, has an extra barb on it. But it's nice to get a kind of a big picture because it jumps out at you that this is an extremely windy area, whereas this is not. So it's a nice contrast to the little barbs here. They're cute. And then the third option is streamlines. And this is kind of neat because you get a bigger picture of the general patterns. And again, the arrows are pointing toward where the wind is going. So the wind is coming from the southwest, going toward the northeast. And if we look at top of lift, this is going to be some higher up systems. Now let's jump down a little bit and see if we can see any greater resolution. Let's go down to the 16. Okay, so we've got some pretty tight lines, pretty consistent upper airflow. By the time we're at 16, we're kind of in an upper airflow where we're not really affected by surface or topography. Move down to 14, still not too much. By the time we get to 12, we start seeing some surface topography, wind rivers. We start seeing how the lower levels are affecting the wind flow. So this is, now we start seeing you can also start seeing circulations. Now, here's the wind being kind of split around an area. It's probably just not really filled in very well. But you'll start seeing some patterns here. We've got the wind actually coming from the other direction, and it's rotating like this. And that is an indicator of a high pressure. And as you see the colors, there's high pressure. So that rotation clockwise in the mid to upper levels is a high pressure system. Whereas we have this lower pressure system that's coming in. We can't really see it in the barbs here. I wonder if we get, let me get one lower. Now, we don't have a good example of it on this map, but so opposite to a high pressure where it's clockwise, you will see, here we go. Here we've got this wind stream lights coming up like this. And if we had this expanded, which we can do, we see the winds coming up and coming around this way. This is a big low pressure. So it's circulating counterclockwise. So this is how we get an idea of the bigger features. So here's the lower pressure and then the higher pressure here. So this is, that's actually, yeah, here we go. So it's circulating. Find that high pressure. High pressure has moved down to here because we are closer to the ground. So now we're dealing more with surface pressure systems. I hope I didn't confuse anybody there. The basic idea is you have a clockwise circulation, high pressure. You have a counterclockwise circulation, low pressure. It's the low pressure that's going to cause a lot more instability and more active weather. Okay. So that's the wind barb streamlines. You can put that on whatever you prefer. And then you can get winds either from here or from here. And that's basically the winds. Then you can go through whatever levels you want. So just a quick word about these different models. I like to look at the GFS. It is the biggest, widest, most expansive resolution at 24 kilometer. Basically, it's 24 kilometer squares that it then interpolates and joins together. So that's a pretty expansive area. But it does allow you to get weather. I think on this model, it's 4 to 5 days out. You can use the GFS model to get an idea of kind of the bigger picture. I honestly don't use the icon, so I can't talk about it much, except that it's a 13 kilometer, so it's basically half of the GFS. I don't use it, so I don't feel comfortable talking about it. We don't have it at work. The next model is the NAM 12. It's a 12 kilometer model, and it is basically takes it only goes out 3 days. So we'll go back to here. And it takes the information from the GFS and it downscales it. So it's kind of like a daughter of the GFS. But it is higher resolution, so about half. So your squares are only 12 kilometers. I believe it updates just as often. But again, it counts a little better for topography. So as you're getting closer, when you're within 3 days out, you can take a look at the NAM 12, get a little better resolution. And then when you're 1 to 2 day out, the NAM 3 has been really good, pretty good verification for us out here in the last couple years that we've been using it. So again, that's like 1 to 2 days out, 3 kilometer resolution. So now you can see you're starting to pick up some of the mountain features and the valleys. See, I'll zoom in a little more. See, yeah, you can actually like see some of the mountain ranges. So that's pretty exciting. This NAM 3. You know, at work, it's not heavily used. But I'm, as a pilot, I'm crazy about it. Again, weighting everything, you know, against the other models. And again, remembering that a model is only as good as its starting parameters. How close is it to the observations that you're seeing, you know, right now? So the last model I used to use the RAP a lot before the HER came into play. So this was a rapid refresh model, and now the HER is an hourly refresh. Again, I don't know if XCSkies brings it in every hour, but the fact that it is a 3 kilometer and the fact that it updates so often gives it a pretty good validity for the day of flying. Again, compare your models, compare them to your starting point, especially if you have a soaring forecast in your area that gives observed winds. You have a basis on which you can test the validity of the model that you're using. So we like to use the HER, again, like the day of, been generally within about 24 hours. So this is 6 o'clock tomorrow, yeah. And that will give you just a little different indication, a little hone in on stuff. We've got the low pressure down here, a little more topography, and a lot stronger winds at 8,000 feet, as we're seeing. Put this up to top of lift, and yeah, those winds are screaming. Okay. So that's just a look at the models. And then on the day, you can pick a calendar day. Again, you're restricted. If you go down to May 15th, it's going to show you a gray screen. Again, your longest out model would be the GFS, and that's going to only give you 5 days. So you can pick a calendar day by clicking on this, and you can pick the time. Okay, we've got to get back to a day where we can see something. So calendar day, and then the time. It shows your little clock here. Again, make sure that you're set up so that your solar noon is somewhere in the vicinity of noon to 2, wherever you live. And then you can just pick the time here, and then you'll see what models give you what times. For instance, if I go to the NAM 12 on Friday, I'm only going to have the option of 9, 12, 15, 18. That being, again, noon, and then jump to 3 o'clock. So that's just a little quick look at the different models, days, and times available. All right, so really there's only one other feature. It's a great feature that I want to share with you. I haven't been using it that much this year. I need to get into the habit again. Sorry, this was the setting. So let me talk about these icons a little bit. So we've got all your parameters up here that we went through. Your favorites, you can set up all your favorite sites here with the clock, with the model that you want, and call it whatever you want. Here's your settings. You can change it for those of you that like to be in the English or the metric. You can change stuff up. And just a quick mention for those that like to work in feet per minute versus meters per second. The quick and dirty, I'm sure most of you know, is 200 feet per minute is 1 meter per second. 400 is 2 meter per second. 6 is 3. 8 is 4, and 1,000 foot per minute is 5 meters per second. So it's like basically you're just cutting it in half. So if you're going to take it to 11, it's much easier to do that in English units than metric units. But here's where you go to different parameters: Fahrenheit, millibars, etc. You can set your time zone offset here. I don't know what the daylight overlay is. I guess it shows your sun path. I haven't used that feature. It sounds kind of cool. Again, this is your clock. And this, I think you can hone in on where you are. So you'd have to let them use your current location, which for right now we're not. I have used this all over the world. When I flew in Colombia, everybody's like, no, it's flyable every day. We just go out and fly. They never look at forecast. I said, well, I just want to see what like the GFS says, because it's a global model, And I would just go over into a corner and look, and then gradually my teammates would come over, and then by the end of the week, like everybody was coming over and wanting the forecast. So there was some validity to it for sure, and if nothing else, it kind of either gives you peace of mind or gives you something to post analysis with. So it was pretty fun. I used it in Valle, I've used it in France, and although they have some really good European models as well, but you can expand this thing and use it all over the world. It's great. All right, so the last thing, and this is in the tutorial as well, is you can click on a point and you can see basically the weather for that particular point for like a whole day. So I'm going to zoom in a little bit and show you the site that we like to fly quite often, especially in the spring. It's called Inspo. Gavin, I'm sure you're familiar with Inspo.
Yes.
So it's down here in the Orem Provo region. Let me get to usable lift. We have winds at the top of the lift. Get rid of my clock. And we'll go Friday. Let's use the NAM 3. Probably have to go back to noon. Okay, so this is in 2 days' time from when I'm talking at noon. I'm going to take a flight from Inspo. So I'm going to get that kind of in the lower part of my screen. So this is Timpanogos, if you guys are familiar with the area. Here's Route 89. These are the Cascades. So the launch is probably down here in this yellow. I'm going to click up right there. And the first thing it gives you when you click on anything is a comparison, the 4 models of top of usable lift. Let's see, if I were on a different setting, let's say Cape, and I clicked, harder to find your spot. If I clicked in a similar region, it would give you the comparison of Cape. So whatever parameter you're on, it will give you that straight up, that comparison. So let's go back to usable lift because we have lots of pretty colors. And here's our site. So here's our overlook at noon, top of usable lift. Pretty nice. We're already, if you believe the NAM 3, which I like to believe, you're already at 12,000 feet at noon. So telling me it's an early day. You can compare. There's 4 different components you can use here. Compare. So it gives you all of these parameters and it compares them to all of the available models. So these aren't available yet. So it's pretty cool. New top of usable lift, lift above the ground. So obviously where I clicked was about 10,000 feet. So I think I clicked a little high because launch is about, I think it's like 7,400. What the thermal tops are, compares the thermal index. Again, thermal index, we want that higher number. So surface temperature, looks a little chilly. No clouds yet. So we can see all of that data by just clicking on compare. The second of 4 possibilities is you actually get a skew T. So here's what we've been talking about, this skew T. There's a lot of great tutorials online. If you punch in SKUT, gives you an idea, but super quick overview. You have your temperature. Ooh, did that explain something? There's probably an explanation in here somewhere. Temperature and dew point. So if these two lines touched at some point, that would probably be your cloud base. They're not getting close, somewhat close at 500 millibars. So that's probably not going to get many clouds in this particular location, if any. And the fact that they're so far apart, especially in the mid layer here, means it's pretty dry environment. So you can just get a quick overview. Again, temperature, dew point. When they meet, that means your relative humidity is 100%. And again, you're probably going to have clouds. These numbers on the side are the surface, the millibars, where you're at the surface. And here in Salt Lake, we're at about 850 millibars here. So at launch, we're probably 820 or about 800 millibars. So that's why we start off down here. So two key levels you want to look at, as I talked about in the very beginning, are the 700 millibar, which is about 10,000 feet. If you're flying in the mountains, it's a good area, especially around here, because this 700 lines up about with the top of the Wasatch. And then the next one up is 500. That's about, you can see these feet right here where my cursor are. It's about 18,000 feet, again, the limit of our flight. So good to look in this area. And then this is a cool thing, little photograph. So this shows you basically what the track of the balloon would be if you launched it right here and you're going up in elevation. So I'm going to come over here and I'm going to move my arrow up and watch the little red dot over here move toward the southeast. So you're saying, there's a northwest wind. And then you look at the wind barbs over here and you say, there's a northwest wind. So it's just kind of a cute little visual aid. So again, that is sounding expected model sounding from the NAM3 for that particular day at that particular time. All right, the third option is the point cast. This is really cool because it takes you through, looks like 3 days of activity at this site. And you look at it, you just do a quick glance, you're like, okay, I know when the middle of the day is. Middle of the day Wednesday, middle of the day Thursday, middle of the day Friday. Typical diurnal heating. Sun heats everything up, mixes things, and we have thermals that go up. So this red line is top of the usable lift. So we can see on Wednesday, top of the usable lift, something happens and it actually gets to its peak of 12:03 late in the afternoon. Thursday is a different day. Gets to its peak, still gets to its peak later in the afternoon, but it's a much lower peak. And we know this is a post-frontal day. And we can tell the difference because here's the southwest prefrontal winds at about 11,000 feet, 10,000 feet, or 700 millibars. And after the front goes through, we have the northwest winds. So a little more stable, a little lower heights. We're only getting up to 96. What's Friday going to be like? Looks about the same, maybe even a touch weaker. So this gives you a nice little overview of that particular site. And then the last feature here is the route. So I want to go, see, I'm going to move this out of the way for a second. There's a little bit of knobology to get used to on this, but it's pretty forgiving. So again, you want to put your point maybe at the edge of where you think you're going to be traveling. The barbs tell me where I'm going to be traveling. So I only fly crosswind in competitions and when I have to. So I'm going to start about the inspo launch. Let's see. I have to put my route out. So there's my one. I'm going to fly to, let's say, I'm going to fly to Timpanogos over here. It's a great place to get up. And then I'm going to fly over the back to the Heber Airport. Right there. Okay, so that's my route. And then this little jumpy thing down here is saying, okay, are you ready to use me? Yes, I'm ready. So this is the information along your route. And that is totally cool. I love this feature. I haven't used it enough to verify its accuracy, so I can't put a lot of weight in it, but it's super fun to look at, and it's very helpful if you look at it before and then you do your post analysis. That's the best way to get familiar with this at any particular site. But it definitely shows you, okay, this is for Friday starting at noon, and here is the time. Let's see. You've got the red line is your top of usable lift. So this is your distance in time. Let's see. This is your time. So you're 3.7 hours out. So you're basically like 3:30. You're going to be getting up to 12:03. But by 5 o'clock, you're peaking out at almost 14 grand. And then 8 hours in, then it's basically game over by then. And you're back to, I can't believe there's that much lift after midnight. But it gives you all of this information, which is really, really good. And then you can see the winds in your layer. Let's see. LCL is what I was talking about before. That's kind of a proxy for cloud base. So top of lift is generally where the lift starts really slowing down. And it takes it from that point to cloud base. It may be similar, but generally I find around here, it just takes that extra special strong thermal to get you up a little higher. And sometimes that is the LCL. The LCL is cloud base around here, and it's pretty darn accurate. Not going to happen after sunset. This is just probably an artifact of, the surface layer separating from the upper level winds. And you can see the difference between the two. But when it's contouring your top of usable lift, again, weight this product, but you have an understanding that, okay, I'm probably going to get up to 13. But if I get that super special thermal, I might get up to 16. If I'm deep over the mountains, if I see those clouds, I could have this possibility. And this has worked out for us on the flight yesterday. I mean, it said Soaring forecast had top of lift at, I think top of lift was 14 and LCL was 17, one of the two. And a lot of us were getting up to about 14 or 15. And then another pilot did get up to that cloud base at 17. And so you just had to get that extra little special thermal to get up there. But again, just click on it, use it, play around with it. You can alter your selections by, if you make a mistake, you can click on it and click to another one. And you can add 4 or 5. And this little guy will keep jumping until you're ready to click it. So that's that feature. That kind of runs through everything. So just real quick, I'm going to sum it up with the 5, my big 5, the ones that I use. Again, this is the 6th thing that I use in my forecast. But when I do, I look at, so I've already got the big picture in my head. So I look at the winds. When I look at the winds, let me clear this off. When I look at the winds for a site, sorry, that didn't go away. I like to start with since I already have an idea of what the day's like, I know if it's going to be prefrontal, southwest, postfrontal, northwest. Zonal flow when I'm in between systems is generally a west. So I'm going to start with the elevation of the site that I'm flying. And let's go back to inspo, 7,400. So I'm going to look at 8,000 foot winds. Again, for the day at the time with this model. Okay, so this is my starting point. I know it's a southwest facing site. Looks pretty happy. It looks pretty good. Okay, so second wind field I look at is the surface winds. I know I can launch, and now can I land? So I click on surface. Here's my site. I'm going to rearrange this. and hone in a little more. All right, so I know my landing fields, if I don't go up and go away, are out here in the valley. And it looks like a nice, mellow southwest flow again. It's good direction for landing. If I had to land at 12, I'm fine. So then I look at 12,000 foot winds is pretty key in our area. Again, that's just above, at or above like the peaks in the Wasatch. So it looks a little healthier, but actually 10 knots, that's pretty sweet. I think, at this window looks pretty good. And then the last thing I'll look at, for a quick look, is the top of lift. Okay, so I'm not seeing any big warning signs. I'm definitely seeing, like, if I go up to temp, get rid of my clock again. If I go up to the temp peak, I might be dealing with some 20 knot winds. So I just need to be aware of that possibility. But I don't have to go right over the peak. I can stay on the shoulder. I can stay out front, but I have an idea of what's going on there. And then if I have extra time, I might take a look at a 10,000 and a 12,000 foot layer. Again, it's looking pretty good. So then I've got my launch and potential land time parameters, and then I'll take it out. Now this model isn't going out any further, so let me back it up to the NAM 12. And do we have, yeah, there it is. So we have a 3 o'clock in the afternoon. So now I can see, at least according to this model, let me go back to the 12 and just see how it compares. Okay, so the 12 is already stronger than the NAM 3 was, and then it picks up even more at 3 o'clock. So something to be aware of. Again, as you approach your day, then you can hone in on the NAM 3 and the HER, the high resolution rapid update models to see what the difference may be. 15 for me at 12,000 feet is really on the edge. So this is, for me, is an indication that I've got to do a little more research day up. And then let's check when I'm maybe going to land somewhere at 6 o'clock. Those 12,000 foot winds are definitely stronger, but maybe I'll be closer to the ground landing, and they're super light. So there's definitely, when you have the difference of direction or strength of that much significance, you're going to find some shear in there, and that's going to give you some turbulence. So you may say, okay, it's going to be super light. I can land, no problem. But somewhere coming down, you're probably going to hit a pretty unstable, sheary, uncomfortable layer. It's just good to know about that stuff. And again, this is just for the NAM 12. So that's an example of how I would use that. So that's winds. That's one of the big 5. The next one I look at is very important, the lifted index. This is one of the key parameters for instability. We'll go back to, we'll just stay on the NAM 12 so we can compare the 3 times. And I'm going to zoom out so I can see my whole route. As you can see from my southwest flow, sometimes we like to take this up to Park City and then, possibly beyond if it's good enough. So at noon, our lifted index is pretty stable. So I'm going to attribute that to the front that passed through the day before, and it just hasn't gotten unstable enough yet. It's getting close. It's actually the Heber launch, so I know what area that is, and it's a little higher up. So I see something like this. I know either A, it's not an early day, or B, I'm going to have to launch high so I can get above and get the thermals that happen above this stable layer. So let's see what happens later in the day. Okay, things lift up a little bit. Still kind of a stable day. If I had the whole day and I could travel to fly, now this is UNS. You want to stay away from that. Okay, maybe I'd go down south. So here's the Richfield area. They got some great sites down there. Cove Mountain, junctions down here. Even Cedar City has some launches, so that might be a consideration to go somewhere else. But again, this is just one of the parameters. But lift and index is that this yellow is the sweet spot number, and 3 o'clock in the afternoon is a pretty good indicator of what you'll get. So that's number 2. Number 3 is the Cape, another very important instability. There's some Cape potential over the Uintas, but knowing from the big picture that it's pretty dry, I think we're probably good there. And number 4 is cloud base and depth. So again, not much to help you along your route, but not much to provide overdevelopment either. So, and of those clouds, they're going to be 5,000 to 6,000 feet deep. So that probably won't fly over the Uintas that day. That's parameter number 4. And then the last one is cloud cover, which again might be an indicator of overdevelopment or things shutting down, in which case if you're using, let's say, go back to the GFS, because we can separate cloud cover and high cloud cover. So nothing, so no clouds, which is good and bad. But if you were flying down here near St. George, you might have a pretty good cloud cover, and that's all high clouds. So you really, again, you don't really have to worry about that. It's not going to help you on course, but it's not going to shut things down. So those are the big 5 that I use. So I have my pre-settings. I can glance at stuff. And again, this is the final process of all the other things that I look for. So that pretty much wraps up my use of XCSkies. I'd be happy to answer any questions that you have, Gavin, or that anybody has. They can email me with questions.
Lisa, that was terrific. I think we should leave it there because that was comprehensive and fabulous. Thank you so much. I really appreciate it.
Oh, you're so welcome. Thanks for having me on the show. I'm a big fan, and it's an honor to be here, Gavin.
That's an honor to have you. Thanks, Lisa.
Thank you. I'll see ya.